So this is the system of linear equations in two variables. To break this down a little bit, this says a system of linear equations. So here we're going to have two linear equations in two variables. So those two equations are going to have two variables in them, and they're going to be called x and y. And so what we want to do is we want to be able to find a solution to both of those equations, but it has the same x and y values, and they're both satisfied. So that's a little confusing, but let's look at an example of what I'm trying to say here. So example 1, given the system, and this is how you write it if you have a system. So I'm going to have two equations here, two linear equations, and they're going to have two variables. So given the system, x plus 2y is equal to 2, and x minus 2y is equal to 6. So that's our system of linear equations in two variables. We have a system of linear equations, which are these two. So a system means more than one. And then in two variables, meaning x and y. So we have x and y in both of these equations, and we want to find an x and y value such that both of these are satisfied, meaning that we plug in x and y here, and this top equation equals 2. And we plug that same x and y into this equation, and that will equal 6. So let's look at just some sample ordered pairs, and let's see if it's satisfied. Determine if determine if the ordered pair is a solution. And we're gonna look at part A, and this is going to be 4, negative 1. And then we're going to look at part B also, and we're going to determine if that is a solution. So the way you do this is, this is your x value, and this is your y value. And you simply plug this x and this y into both of these equations, and you want to see if this one equals 2 and if this one equals 6. Alright, so let's look at that. So I'm just going to write both of these right here next to each other, and then we're going to work down plugging in these values. So the first equation is x plus 2y is equal to 2. And then over here next to it is going to be x minus 2y is equal to 6. So I'm just going to work this side first, and then we'll do this one next. So we're plugging in our x and y values here. So x, we said, was 4. Plus 2 times y, which is negative 1, and I want to know if that's equal to 2. So that's why I'm writing a little question mark. Is that equal to 2? Alright, so let's keep simplifying. 4, and then 2 times negative 1 is negative 2, and I'm still trying to determine if that's equal to 2. And then the last step, 2 is equal to 2. And if that's true, then yes. So this one works. This one's good. This one's true. Now this, when we plug this x and y value in, it has to be true for both of these equations for this ordered pair to be a solution to this system. So we have to plug in these x and y values also. So x, we said, was 4 minus 2 times y, which is negative 1. And I'm questioning, is that equal to 6? Simplify. 4 minus, and then 2 times negative 1 is a negative 2, so this becomes a plus 2. And I'm still questioning, is that equal to 6? So 6 is equal to 6. That is true. Yes. So this means that 4, negative 2 is a solution to the system. So now let's look at another example, part B. What about negative 4, 3? And I encourage you to work this by yourself. Alright, I'm going to go ahead and go here. So I'm going to do the same thing. I'm going to work both of these equations. x plus 2y is equal to 2, and x minus 2y is equal to 6. And I want to plug this same ordered pair into both of these equations. So when my x value is -4 and my y value is 3. So I'll plug those in here. X is -4 plus 2 times y, which is 3, and I'm questioning if that's equal to 2. Doing some simplifying, -4 plus 6, and I'm questioning if that's equal to 2. So 2 is equal to 2. Yes, this one is true. Alright, now we have to check this one. Plugging in the same values, -4 minus 2 times y, which is 3, and I'm questioning if that's equal to 6. Simplifying a little bit, I get -4 minus 6, and I'm questioning if that's equal to 6. Simplifying, -10, and I'm questioning if that's equal to 6, which it is not. So this is false. So this is not, I should say -4 comma 3 is not a solution. So that's what the next several lectures are going to be about. It's looking at linear equations in 2 variables, and then we're going to look at 3 variables. And what we want to be able to determine are the points or the ordered pairs that give us the solution to this. So in the next examples, and from now on, what you're going to see is I'm just going to ask, determine the ordered pair that is a solution of this. And so from this only, this system, you have to tell me that the answer is 4, -1. So let's look at one of those examples now. All right, and so example 2. And let's just say find the solution of this system. 5x minus 4y is equal to 9, and x minus 2y is equal to -3. That is an x, but it's very ugly. Alright, so the first thing we want to do here is I like rewriting what we have. It'll make things a little easier, a little cleaner. It gives us some room to work. So what you want to do is you want to take one of these equations and you want to solve for one of the variables. So pick the easiest one. What I mean is we can take this second equation of the system and we can get x all by itself, and that one's really simple because there's no coefficients. All I have to do is add 2y to both sides. So let's do that. So I'm taking this equation and I'm just saying I'm adding 2y to both sides. So that gives me -3 plus 2y. Alright? And some of you may not like how that's written. You could have reversed the order here. It doesn't matter since you're adding and subtracting. So that gives me an equation. It says that x is equal to this now. Alright? So what I do is I take this equation that I just rewrote, and now I plug it back in to this top equation up here for x. So this x right here now becomes -3 plus 2y. Alright? So 5x, and I'll just go ahead and rewrite it. You don't necessarily have to. So I'm going to use this equation and I'm plugging this in here for x now. So it's 5, and this x is replaced with -3 plus 2y. And then this -4y is still here, and so is the 9. So what took place, what happened here is I took this x and I said it's equal to -3 plus 2y. That's what we just found down here. And simplifying means I have to distribute this 5 into both of these terms. So I get 5 times -3 is -15. 5 times 2y is plus 10y. And then this -4y is still here, and that's equal to 9. So look at what this did for us. We started out with this equation in terms of x and y. Then we replace this x with this minus 3 plus 2y, and the resulting equation is an equation that's in terms of one variable, only y. So now if we solve this for y, that will be our y, that will be the y value of the solution for this system. Alright, so let's keep going here. So we can combine like terms. Negative 15 plus 6y is equal to 9. Then I need to add 15 to both sides. So 6y is equal to 24, excuse me. And then I need to divide both sides by by 6. So y is equal to 4. All right. So that is our y value. Now, how do we determine what our x value is? So we already know our y. So all we have to do is pick one of these equations and plug in our y value. So if I take this y equals 4 and I plug that in for this bottom equation, then I'm left with an equation that's in terms of only x, and then out will pop my x value. So let's take this down here. X minus 2y is equal to negative 3. So I'm taking this y and I'm plugging it in there for that y. So 4. X minus 2 times 4 is equal to negative 3. Doing some simplifying, x minus 8 is equal to negative 3. Add 8 over, so x is equal to 5. So the solution is 5, 4. And then what you want to do you want to check. You want to check it by taking this 5 and this 4 and plugging it into both of these equations. That would be your final answer. The reason you check is because sometimes you may get 2 answers and one of the answers may not be correct. But in this case, when you check it, these would come out, and I encourage you to give that a try.